So I'm gonna do a slightly different, use a slightly different approach for my talk. And I will discuss mostly about the relationship between inflammation and depression rather than chronic fatigue syndromes or other conditions. And I wanted to do this first to give you a general background on how the field has evolved over the years, in general, why the field has become progressively more interested in measuring inflammation in the context of disorders that were not immediately clearly due to an immune disturbance, but also to give you an example of things that can be done that have not been done yet in chronic fatigue syndrome, which have been used, study designs or methodology which have been successfully used in patients with major depression. Now, of course, the fact that differences have been found in patients with major depression doesn't mean that the same differences will be found in patients with chronic fatigue syndrome, because there are two different conditions, as we discussed already when I gave the previous talk. But nevertheless, it gives some way of looking at the complexity of the interaction between the mind, the body, the brain, and the immune system. Now, for those of you who don't know this, actually this is an area which has been developed quite a lot over the last few years, but actually it has been around for a long time. And I'm the editor-in-chief of this journal called Brain Behavior and Immunity, and the journal was founded 30 years ago. So it has been the notion that the brain can be connected to the immune system, and that can be connected to behavior, or in fact emotions or physical sensations, something which has been going on for quite a long time. And just my own personal experience, I've also been around for quite a long time, because that's my first paper, and as you can see, it was published in 1991. Quite a long time ago, but already was talking about psychological status and immunological parameters. So it's not only kind of a personal interest, but something which is, as I said, has been going on for a long time for myself, but also for the scientific community. Now, I think the principle, the overarching principle that I want to convey is the idea that the immune system is not only some kind of army that is keep bacteria and virus away from our body or protect us when we are invaded. Okay? I mean, of course, this is important, and it is the way the immune system makes us survive. But the action or the task of making us survive to infection is not simply just by killing virus and bacteria or helping our wound healing system, but really through connecting and regulating reciprocally with the brain and with emotions and with behavior. Now, there's two, as you can see, the communication is bidirectional. There are, in fact, two ways of communication. This, if you like, the communication between the immune system to the brain and to the way we feel and to the way we behave is perhaps the one that we're all more familiar with. I mean, not also, of course, if you experience severe fatigue or disabling fatigue as part of chronic fatigue syndrome, for which this link, although hypothetically interesting, has not been found completely yet. But even in a much milder and everyday experience of having a severe cold or having temperature or having an infection, we all know how we react as individuals to that experience by feeling tired, of course, and wanting to withdraw socially, and maybe feeling moody and having disrupted sleep and disrupted appetite. So somehow in our DNA, in our body, the immune system knows how to communicate to the brain about the presence of an infection, and communicate to the brain so that the brain acts to create a lot of behavioral consequences which are really important to fight the infection, both as an individual and, if you like, a societal level. So the prevalent model to explain why the immune system communicates to the brain is that by feeling tired and unable or unwilling to move and unable or unwilling to engage in social activities, we save energy to fight the infection, and we, of course, avoid spreading the virus or the bacteria to the wider community, because we will self-isolate ourselves. So there are somehow some pathways that are written into our biology, so that if something goes wrong in the immune system, and at any point this signal that should be helpful during acute infection becomes unhelpful and become pathological and become maybe established or chronic, of course you may still have the consequences without having any beneficial effect. But as I said, the communication goes the other way as well. So the brain is able to communicate to the immune system. And again, this is also important for exactly the same evolutionary mechanism. And the classical communication between the brain and the immune system is the ability of the brain to communicate to the immune system the presence of a stress in the environment. So every time that we experience what we consider psychosocial stress, being under threat, or being or bereavement, or any kind of condition that we perceive as stressful or threatening, is signaled to the immune system, and the immune system gets activated, as if it was encountering a virus or a bacteria. So this, in a way, it's kind of the reason why when I presented my data early on during the day, and I discussed about what happens early on in the life of an individual who then develops chronic fatigue syndrome, ME, and why some individuals develop chronic fatigue syndrome, ME, following a stressful life event, is not because I believe that stress is psychological and CSF or ME are psychological, but because stress has profound biological effect, including activating the immune system in the same way that with a virus or a bacteria. So this communication is also very important, and evolutionary advantageous because, of course, for centuries or for thousands of years, infectious disease was the reason why people would die, until we have antibiotics and improved our kind of this hygienic, standard hygienic condition. Not only that, for thousands of years, stress most of the time would actually represent predators, would be physical stressors. Only recently, in the last 100, 200 years, we start to be stressed because we're poor, or we're unemployed, or we break up a relationship. Historically, stress was there's a lion, and we need to run away, and there's a risk for life. So you can see how this mechanism operates for exactly the same evolutionary mechanism. And I guess I'm doing all this conversation so that some of the misconception or misperception about the relationship between of a model which wants to integrate stress, potentially the stress with the intercommunication of the brain and the immune system in the pathogenesis or in the understanding of at least some individual with chronic fatigue syndrome or ME, has nothing to do with psychological model. It has nothing to do with wanting to undermining or giving a psychological explanation of the illness, but wants to really I want to kind of give you all the information available so that you can see how this communication is there for a reason. But again, it could go wrong, and it is possible that perhaps a life event which should have just given a one-off, very brief activation of the immune system actually transform into a cascade of persistent activation, which then participate to chronic fatigue syndromes. And again, these are all hypotheses, because then, of course, if we measure things, as we've heard from my predecessor just a few minutes ago, actually, if you measure things, you don't find a lot of evidence of immune activation when people are ill with chronic fatigue syndrome, but that doesn't mean that something hasn't happened before at a stage where we've not been able to measure. Now, I know I don't have a lot of time, but I want to give you a snapshot of what has happened in the field of depression, again, because I think both methodologically but also historically can guide us in what could be done for chronic fatigue syndromes and ME. Because the only reason why the inflammation has become important in the field of depression and in the field of psychiatry in general is because it's opened up the opportunity of therapeutic intervention. So this is one paper, this is an article that was written on Nature Medicine, which probably all of you know is one of the most prestigious scientific journals, a couple of years ago. They also mentioned my research is actually a freelance journalist, and she came to interview me. And the article is about why the next wave of antidepressants may target the immune system. So something that we need to think of is that if we understand what kind of abnormality is present, if there is, and at what stage in the immune system the patient develop, either they will develop or they have developed chronic fatigue syndrome, that could attract potential interest and investment from pharmaceutical companies, which would then try to, either for the development of new medication or, as you probably all know, by using anti-inflammatory drugs in the context of chronic fatigue syndromes. Again, the trials so far have not been very promising, but perhaps because we are intervening maybe too late or with the wrong molecules. So I'm giving you more questions than answers, but I wanted to kind of, at the same time, give you also the fact that this approach can be successful and has been successful in depression. And we're just maybe only a few years behind in chronic fatigue syndromes. I won't go through this picture. It's kind of is putting back the same idea that I mentioned before, that somehow there's a mismatch between the way our stress systems work, which is still the stress system of a man in the jungle in finding a lion, and the current kind of modern society. And perhaps within that mismatch, there's also why some of these consequences become pathological. Now, as I said, I'm just going to give you very kind of snapshot of data. This is a study that we published, as you can see, 10 years ago. We were one of the first groups to demonstrate that inflammation in depression does not come in isolation. Doesn't come as a single biological abnormality, but in particular coexist with abnormality in cortisol levels, so in the level of the main hormonal stress response systems. And I'll tell you why I think this is relevant for chronic fatigue syndromes. So the classical, so we found that if you just take one sample, this is one blood samples, fasting blood samples in depressed patient, you can measure a higher level of interleukin-6. This, you will remember, this is the same cytokine that is elevated early on in the patient that develop persistent fatigue in the interferon alpha model, exactly the same. But interestingly, this patient also had high level of cortisol, which is the main hormone produced by the hypothalamic pituitary adrenal axis in response to stress. Now, why I think is important, why I've mentioned this in the context of this talk, is that cortisol and inflammation are supposed to work one against the other. So cortisol is, among other things, an anti-inflammatory signal. So in fact, if you have an acute inflammatory condition, or either through infection or rheumatoid arthritis or autoimmune disorders, having high dose, pharmacological doses of a cortisol or equivalent of cortisol is one of the therapeutic strategy. So within the kind of community of scientists trying to understand the role of the immune system in depression, there's been a lot of questions of how these two systems, they should work together, actually, they should work one against each other, actually works together. So I always use this picture because you have the water here, which is the cortisol, that should keep the fire under control, but actually the fire keeps firing. And both of them are elevated. Now, there are studies, as you all know, on chronic fatigue syndromes and cortisol. And there have been, in fact, more than one, and there have been even meta-analysis of synthesis of many studies, which, and arguably, one of the most replicated findings in the biology of chronic fatigue syndromes and ME is a lower level of cortisol. So from that point of view, depression and chronic fatigue syndromes are, yet again, at the opposite spectrum of a biological abnormality. Again, certainly not overlapping, if anything, on the opposite spectrum. But the question is, of course, is it possible that one of the reasons why inflammation may contribute to the symptoms in the context of chronic fatigue is because the cortisol level is lower and cannot keep the inflammation under control? And if we cannot find evidence of immune activation when the illness is present, is this happened before? Is the low level of cortisol, for example, something that people experience, maybe they've always had, is a risk factors that explain why then some individuals, when they do encounter a trigger because of an infection or a trigger because of a life event, their immune system tend to respond in a hyperactive way. Again, if we can use some of these techniques and some of these approaches, we may find some of the answer. And I'll skip this for sake of time. Now, of course, genetics is important. We've been talking about genetics for a long time today, and the approach has always been that of most recently to do genetic studies which involve many thousands of people. And one of the things that we discussed in the workshop earlier today was the need of putting together such a large amount of patients that we would be able to pick up a signal that would be above the noise. But in depression, for example, there have been quite a lot of genetic studies, even by looking at candidate gene studies. They've shown that there are some polymorphisms. Especially, this is a review that we published a couple of years ago, in fact last year. And in the large amount of genetic studies, there is definitely, in the context of depression, some signal. Now, the individual polymorphisms are not important. You can see here IL-6, so the gene, polymorphism in the cytokines gene that we've discussed before, and in IL-10, which I also mentioned today. Other important cytokines are MCP1 and TNF-alpha. So there are, for depression, clear evidence that some polymorphisms are associated to both an increased risk of developing an activated immune response and an increased risk of developing depression. So again, perhaps the reason why some individuals are at risk of developing chronic fatigue in the context of immune activation is that at some point when the immune triggers arrive, either through infection or life event, it interacts with a genetic predisposition in one or two maybe immune genes, and which then explain a hyperreactive immune response and maybe the origin or the establishment of this fatigue. It is possible that any of these hypotheses or findings in depression can be moved, can be replicated, or maybe can be tested and demonstrated to be different in chronic fatigue. One thing that has been becoming progressively more important in depression, but on which there has been little studies until now in chronic fatigue syndromes, is the potential contribution of the in utero environment. Because, of course, what I've said about inflammation and infection and inflammation and stress at any stage in life is as important during pregnancy, where, of course, a woman may have higher level of inflammation during pregnancy because of stress or clinical depression, as I'm going to show you in a second, but also because of infection or because of medical condition. And in depression, in the field of depression, there is some data, and I'm going to show you some from our own group, linking high level of stress in pregnancy with high level of inflammation in the mother during pregnancy, with high level of inflammation in the offspring, so in the children, and high level of depression in the children. So this path between adverse in utero environment to immune activation, to changing the immune system of the child and increased risk of the child of developing depression when they become adult, is something that Again, is a model that should be interrogated in the context of chronic fatigue syndrome as well. Again, not because of any psychological contribution or anything to do with mother-infant relationship, but because of the biological signature of immune activation going from one generation to the next. And so this is a study that we published very recently comparing mothers who were depressed in pregnancy. We used depression as a model of an activation of the stress system and the immune system. We found, again, interleukin-6 and interleukin-10. You can see them returning over and over again to be elevated in mothers who were depressed in pregnancy. I'm really sorry you cannot read this very well, but that's cases and that's control. So they're higher interleukin-6 and interleukin-10 in mothers who are depressed during pregnancy, and with consequences also on the obstetric outcome. In this case, for example, a slightly shorter gestational age at birth and a slightly smaller baby. And also, interesting, a baby which is more reactive to stress. We used the vaccination at 12 months to measure the cortisol response of the baby, and we found this link. Here you can see a healthy baby born from a healthy mother actually does not show any cortisol level increase between before and after the vaccination, but the babies born from mothers who were depressed in pregnancy show this hyperreactive cortisol, this cortisol going up. We have no idea of how this would potentially apply. Is this a signal? We suspect this is a signal of risk for future depression. We know from other studies that these babies will also have more risk of having high level of inflammation and developing depression. You can see an early signal of this predisposition. This is an area where we have very little understanding yet in the context of chronic fatigue. So I really want to finish with this notion that there are aspects of our understanding of the relationship between stress, psychiatric disorders and depression in particular, and stress, and the communication with the brain, and the communication with the immune system, that not only are totally based on biological models and not on psychological or psychosocial, but totally biological models, but also that from this understanding of this profound connection between the immune systems and the brain, which was given to us to protect us from infection, there are certainly elements that can go wrong and can, perhaps in different individuals, predispose or cause or increase the risk of depression, maybe in some subject, chronic fatigue in some other subject, and so on. Thank you very much for your attention.